can see I work for VMware as the Grails advocate there. This is my Twitter ID, Twitter handle, Google+, some people do use that apparently, and my email address. So, going to talk about Groovy and Grails for Java developers. So, are we Java developers here, or mixed background? Mixed. So, what's your background?
Well, Java, Rails, and PHP now. But
Rails and PHP.
yeah, but I have to.
I do a lot of Java and also Python and JavaScript.
Okay. Yeah. So a broader range than I usually encounter, which is cool. Anyway, so not much in the way of Groovy experience. Excellent. So I can do the introduction. Groovy, dynamic language for the JVM, like your Ruby or JavaScript on the Rhino. But it's kind of unique in that it's got that Java-like syntax. If you are a Java developer and running on the JVM, you pretty much know the syntax already. And it interestingly has this thing called optional static types. So whereas Ruby and Python, don't have any real types at all, you always declare def or whatever. You can actually declare your variables with types. And this is pretty useful for things like Grails. And right at the end of the Groovy section, I'm going to be talking about some interesting new feature coming in Groovy 2. But I'll leave that and keep you on your tenterhooks until we get there. So, unlike some of the other languages, Python or Jython and JRuby have their own class library. Groovy doesn't, it uses the standard Java one. It uses JDK, but extends it. You're going to see some of the extensions and why it makes it easier to work with. And you also see that it supports scripts as well as classes. You get this seamless integration with Java, which means that you can compile Groovy and Java files together. Java can call Groovy, Groovy can call Java. So you can mix and match to your heart's content. Use whichever is appropriate for particular classes or even particular projects. And it also has pretty good support in the IDE department with Eclipse as a well-maintained Eclipse plugin. Especially my colleagues in VMware work on that. And IntelliJ always just have very, very good Groovy support. So, what's it look like? So I'm going to start with introduction about the syntax, some of the features it adds, and then look at some of the ways that you might want to use Groovy in your day-to-day programming. Especially within, I would normally say within enterprises where you don't actually get much options like Java or nothing else. But there are ways to get it into these companies. Let's begin. It looks like a Java class, baseball team, apart from def, so that's our dynamic types. But these are something called properties. So rather than straight fields, these are something called properties based on Java Bean specification. These allow you to do some interesting things. You get, without declaring a special constructor, you can initialize any property from within this constructor. It's just property name, colon, value. And you can have read-only properties like display name, and that can be referred to using the same property notation as if it's a field. Now, to be honest, when I'm talking to people who are used to JRuby and JavaScript, it's like, yeah, well, whatever. But if you're stuck in Java land, this is quite nice. Having to do those get and set methods is quite a pain. So the point here is that get and set methods are implicitly properties in Groovy. So that's our read-only method. We can also see city names set like that. And under the hood, we actually have the methods. We actually have the get and set methods, so we can call those. And that means you can call them from within Java as well. So going back to that integration between Java and Groovy. We can take this a little bit further and use more Groovy features, especially with functional programming. Immutable types are becoming more popular. So rather than modifying an instance, you create a new one. With a simple annotation, you can make that baseball team immutable. You can't modify it. But to use it, you have to declare your types, because you can only use immutable types in the fields of an immutable class. String, numbers, but also lists. Lists of immutable types are supported as well. and you cannot modify those. So just with that, we get an automatic tuple constructor. So the order of those is the order that you declare the fields, city name, then team name. And then you have, again, if you try to modify city name there, you get a exception, cannot set read-only property. Very straightforward, and boom, you've got immutable classes. Without all the boilerplate you have to write with Java. Okay, so moving quickly on to the types. Of course, they're using the JDK strings, but you get the addition of embedded strings. Similar to Ruby and Python, I think both have these. Little different in Groovy, it's dollar curly braces to put your expressions, embedded expressions in. Okay, so single quotes, standard string, double quotes, you get the variable replacement substitution. You also have array style syntax for accessing individual characters of strings. So again, I suspect Ruby and Python allow you to do this. But Java, you do not have this feature. And also you get indexing from the end of an array with -1. Okay, so there we go. G for the beginning of the string, L for the end of the string. And you can do fancy things with ranges, so say characters 0 to 5 inclusive, indexing from 0 of course, and you can reverse that range to get a reversed string, like so. Very quickly, multi-line strings. You guys are not impressed because you have them in other languages. Why multi-line strings aren't in Java, I do not know. They really need to go in that. You also have support for, you have triple single quotes or triple double quotes, and they behave exactly the same way as the single quote versions. So you can have very simple templates using the triple quotes here. So you just say, recipient, author, they will get substituted in. If you want to do emails, template emails, that kind of thing. Now, one of the most common problems in Java land, if you're dealing with floating point in arithmetic, is this problem. 2.0 minus 1.1 does not equal 0.9. Equals 0.8999999, recurring. Of course, the arithmetic is fast, but if you're doing financial applications, it's not so great. So, in Java land, you have to use the big decimal class, and that is painful, very, very painful. You have to instantiate your big decimals, then you'll use all these subtract plus methods. With Groovy, you find that if you just use the standard floating point numbers, you get big decimal out of the box. It uses precise arithmetic, which is great in typically when you're doing scripts, and you're getting the exact results that you expect. Of course, it's slow, so you don't use this for floating point arithmetic if you're doing those kinds of calculations where you need speed, but you can get a floating point by adding a d at the end of the number or just declaring something as double. And notice no sign of those subtract plus methods at all. You're using the standard operators. That's because Groovy adds operator overload. And in fact, you can add your own operator methods and get that operator support for your own classes, such as matrix class is something that I often demonstrate. So, Java 2 introduced collections, but unfortunately, because it was added after the language, you don't really get much in the way of language support for them. So, Groovy rectifies that, so you get your standard literal lists, you also get literal maps, but you also get extra methods. So this is where Groovy uses the JDK, but it also extends it, and that's because it's a dynamic language that allows for that. So you've got something as simple as a join method, which takes a list of items and just turns them into a single string separated by whatever you give to it. So a comma in this particular case. Maps, you can iterate over using the each method. Again, here you see, this is where we really introduce the closure. This is like that anonymous function, it's like Ruby code blocks, like a JavaScript function without a name. That is effectively what a closure is in Groovy. But it can also the closure can capture variables outside of its scope. So that closure can in fact refer to mymap, for example. We could print ln mymap.size. So very powerful feature there. And that's the results of that. And of course, this is going to come in Java 8, but you get this now in Groovy without having to wait for Java 8, which is due sometime in next year apparently. And of course, you're usually not allowed to use the latest version of Java in many, many projects, so you'll be waiting even longer. But let's filter a map. Find the first item that matches a condition, such as it greater than 10, or find all items. There we go. And this one often confuses people who are used to already functional methods. This is normally called map in most languages. It's called collect in Groovy. And it will just apply a function, which is your closure, it minus 3, to every item in the list to create a new one. So we can see the result. First item goes from 3 to 0, second item 6 to 3. We're just subtracting 3 off each of the items. We have a new list. But you can do more interesting things with that. And then many, many more methods that Groovy adds to the standard JDK. This is just a small selection. Java has regular expression support, but again, like the collections, they added it after the language was really developed. And they really didn't want to change the language much, if at all. I think there were probably big fights over generics and exactly how they would, what form they would take. So things like regular expressions and collections really didn't get a look in, which is a bit of a shame. So in Groovy, regular expressions, you often use backslashes, and of course, with double quotes, in Java land, you need to use backslashes to escape those things. So you end up with lots and lots of series of backslashes. So what Groovy does is introduce a third form of string literal with slash, and then you don't need to escape them. So if you do put a backslash d in there, it is a regular expression backslash d. You don't only need the one backslash. For example, in the next example, backslash w star. Okay, so that's just the string, but we also get the Perl style matcher operator equals squiggle, and that you can use to test, do a condition. Is it equal to true? Does test string match /AIM? I.e., can AIM be found in the source string? Of course it can, that's why this session passes. You can also, out of that, get a matcher instance, and then you iterate over that to get the group information. And you get array style access indexing to the group matching groups in there as well. Of course, it's kind of neat to do that. It's not much in the way of syntax, but of course you can get really lost. So I do recommend you be a little bit careful using things like match square bracket 0, because most people will look at that and go, right now, what were the rules in the JDK again? Which group is that? Is it a group? Is it the whole match? Which match is it? Very confusing. So very neat, but usually worth documenting exactly what match that is. And finally, if you put a tilde in front of your string, it is automatically compiled into a pattern. So that can be for very efficient regular expression matching when you need to match multiple strings, many, many strings against a single pattern. One of the really powerful features of Groovy, and I think Groovy kind of stole the whole build concept of Groovy, they borrowed it, is using the dynamic language to build structured data. So XML is the classic example. You've got nested elements. It's structured, hierarchical. So what we have is a class called markup builder, create an instance of it, and then we call methods on it. And again, we're using closures, but you don't really know that you're using closures. They're just braces. So you can already see that you've got a root sports element, then you've got baseball and football elements under there, and inside of those you have even more elements. So our football becomes an element in the XML, as does rams, but as we can see, town colon translates into an attribute. So you get succinct syntax for generating XML, but because it's Ruby code, you can include loops, code, conditions. So we can say, if false, you're unlikely to have that in code unless you want to very easily switch between false and true. But simply by doing a condition there, we get rid of the XML output. So it is an incredibly powerful way of generating XML. And Groovy 1.8 introduced JSON builder as well. So it's a really useful way of getting JSON. On the flip side, parsing XML becomes a lot easier because XML is structured data, but everything's pretty dynamic. Using dynamic language makes it easier to work with. In this particular case, we have a different class, XML slurper, take in the XML, and that will give us a reference to the root element. And then we can use standard property notation and even array indexing to extract the information we need. So root.language.feature1 will extract that element out for us. And then .text will give us the content, which is template. You can also access the attribute information just using @ syntax. So @name will give us Groovy Perl Java. You can even incorporate standard, those filters that I mentioned earlier, find and find all. So for example, this will find all the feature elements whose coolness attribute is low. Okay? So that was quite sort of a quick run through the features of Groovy. Now how about, what's it particularly useful for? How can you get it into projects, that kind of thing? Of course, that one is scripts. Now, it's not, it doesn't start up quite as fast as Ruby, but I was talking to a company a long time ago, early adopters of Groovy, and they said, yeah, we tried Ruby, but different platforms, there were like too many differences, and it was hard to maintain the script. So we actually went for Groovy because you could deploy it. You could run the scripts on multiple platforms, and it would stay the same. It was write once, run anywhere. There's also, tests. Companies, bosses, they get quite concerned about using something new in production code. But for tests, they don't care. In fact, they should care that you have tests, but some bosses don't even care about that. But the point is that the tests don't go into production, so you generally get more flexible there, and Groovy introduces some interesting frameworks to improve testing. It comes built in with support for JUnit, but I'm going to show you another library that makes it really nice to test Java code, or Groovy code. Java application, embedding Groovy code inside Java applications so you can script those. So you can have a plugin mechanism, or it's the way that text editors have. You can add plugins or extend them through Ruby or Python. You can do the same with Groovy within Java applications. Very easy to do, and very easy to do very simple domain-specific languages. So that people write something that doesn't look like code, but it is under the hood code, but it's very easy to implement. You don't have to write your own parser. Okay, so let's have a quick look at some example scripts. So these are some that I have actually written, so they are real-world examples. The first one is dealing with databases. As long as you have, all you need is the JDBC driver jar on your class path when you run the script. And from that point on, you just create an instance of SQL. So this is Groovy specific class, JDBC connection URL, and now we can execute our SQL statements. So you get each row, select start from user, and then within each row we can execute updates. So this is for working with raw SQL. Now I'm highlighting this because if you notice, it's got G-string there, so you've got the $curly brace. The neat thing is that that will automatically escape the parameters. So you don't have to use positional parameter queries in order to avoid SQL injection attacks. Simply by doing that, you avoid it. Very nice feature. And what did that one do? So that was actually to go through a database and simply anonymize some of the data that was in there, update the email addresses and usernames, that kind, and the passwords. Something that you want to do outside of the application. So I mentioned XML, one of its great strengths. You just grab the URL. Again, we're using closures. Java 7 kind of improves this with their resource abstraction. So you can say, kind of, with these resources, do something, and then they'll automatically and safely be cleared up afterwards. But if you're not running on Java 7, you don't have access to that unless you use Groovy. So you've got things like with input stream. Execute a code block with the open stream, and as soon as it's finished, whether it finishes normally or even if there's an exception thrown, it cleans up the resource automatically. So you avoid all those horrible try-catch blocks all over the place. Again, using XML Slurper to parse XML file that's got a bunch of Grails plugin information. With print writer, so we're now writing to a log file, we're using with print writer again, safely closes the stream, print something out to it. As you can see, we're iterating over the release elements in a plugin element. But it's all code, you're not seeing the XML. So it's concise and easy to work with. A lot of scripting uses the JDK, and that's all you need, but sometimes you need other libraries, at which point you need to either download the jar files and put them manually on the class path when you run the script, or you can use Groovy's grab feature, and that will automatically pull in the dependencies and put them on the class path when the script is run. So that's all you need to do. Write the script, add the grab annotations in there, and those classes will be available to you. In this particular case, it's quite an advanced one here. We're getting hold of the Grails data mapping jar files called GORM, in this particular case for MongoDB. So we have those. We create our entity class, which will be mapped to a MongoDB collection. And then we can do new book, set the title, and save it. And that will go into MongoDB. Okay? So that kind of example is really good for those people who keep on asking us, so can we use GORM outside of Grails? And the answer is, yes, you can. In fact, and it's surprisingly simple just to do it from script. Okay, so Spock is that testing framework I was telling you about. Behavior-driven development, but it has some very interesting features. Now, I always think it's difficult to explain why you should use Spock, because the reason you should use Spock is really because of the way it forces you to structure your tests. You know, in my view, that is the one big win. Unfortunately, it's really difficult to demonstrate why that's the case. Generally, I just say, try it, and then you'll find out. But it has some wow features as well to get people trying it out in the first place. So we'll see some of those. The basic idea is you have your given, when, then. But you can use your standard Java infrastructure as well. So your IDE, can your IDE run JUnit tests? If so, it can run Spock tests as well. For this particular one, I have a little pre-recorded demo. Very useful when you don't have any internet connection. Or, if you're like me, you can't talk and code at the same time. So, this is basic Spock specification. First thing to note, your methods can have spaces, so you have sentences. Test the find positives method. Given a number helper instance, when find positives is called, then we call the find positives method with a list. then it should return a list of all numbers. And then you've got a list of assertions. In this particular case, just result equals 1. That's the only positive number. What I like about this is it's very readable. The way that you add strings after the given and the when means that it's very easy to document the test as you go and explain what's happening. And it's just so easy to get into the habit of doing that. If you look at a standard JUnit test, it's typically pretty messy. There may be some comments around the place, but it's quite hard to understand what the test is doing. Just having this structure improves readability and understanding. And so it becomes a specification. Now, that's all well and good, but hey, I'm only testing one value. What about boundary conditions? What if there's an empty test? What if it's an empty list? Or whether it's all negative numbers? Well, I'll show you what happens then. What I've just demonstrated is I've run this as a JUnit test. This is just using standard Eclipse JUnit test runner. Boom, there we go. Now, I want to test boundary conditions. This is where I use a power feature of Spock. It's a where block. This is what we call data-driven tests. So now, it's still the same test, but I'm providing a bunch of data to go with it. So we now have implicit variables. Data, which I'm passing into the find positives method, and expected, which I compare against the result. So, on the left, I expect an empty list to result in another empty list. 0, 0 becomes 0, and so on and so forth. Okay, and now when we run it, it will fail if any one of those doesn't match, if data doesn't match expected. Okay, so we found that one of them doesn't. What wasn't very clear is you also get very good output from that assertion. It will show you the values of all the expressions. So I've just fixed that. So it will show you all the values of the expression, so it's very easy to see which part of the expression doesn't match your expectation. So it's very easy to debug what's going on. And finally, on this new annotation, unroll. So the problem is, when you have data-driven tests like this, it's all run as it looks like a single test. So you see one failure, but you can't see all of the others. So what unroll does is unrolls those data items and produces a separate test for each one. Even more intriguingly, you can give each test a different name, and that can have variables in it. So we've got find positives for hash data, and hash data is going to take that data variable and put it in the name of the test. So we'll see it when we run this. There we go. So then we've got find positives for empty list, list containing -1, 0, 5. And then if any of those fail, you can see exactly which data item failed. Very powerful feature. Now, quite interestingly, you can extend Spock. I'm not even going to go there because it's quite a deep topic. But somebody was telling me the other day, you can take Spock and say, actually, this is a specification language. And what they did was they wanted to create recipes for cloud deployments. So this requires an HTTP server, a MySQL backend, and so on and so forth. These recipes of infrastructure for applications. So what they did was create specifications which said these are the requirements for a particular deployment. They read that to create the corresponding recipes for Chef or Puppet. So that's the specification, and then they can run the test afterwards to check that the deployment was correct, that it worked. So that's a power use of Spock, but that's the kind of thing that you can do.
What is it called?
Sorry?
The name of the...
Sorry. The name of
Is
That-
in?
Right, so no, that's just something custom that a team did. So it's not publicly available. Although it is an interesting idea. I don't know whether they would be interested in open sourcing it or not. But being able to do that with Spock and take your specifications and effectively apply them as recipes, very powerful. Okay, so another feature we were talking about was implementing a DSL. This is a very simple one. You can eliminate the trades equals curly brace. It requires a little bit more work, but typically you would. But for the simple example, it's in there for simplicity of the code to read the DSL. There's the bit inside the curly braces by 1000 of VMW, so again, very easy stock trading. Few points here, no string literals, no dots, no parentheses. But this is literally Groovy code. How is this implemented? Well, this is all implemented in Java, in fact. Only that input.text is literally Groovy, and it doesn't even have a Groovy syntax. So what we do is, that file is what we call a script, because it doesn't have a class definition. So what we use is this Groovy shell class. That allows us to parse a standard Groovy script, give us a script instance, and then we can run that script. So that's what we do. So once we've run the script, any values that trades equals, for example, that was a declaration of a binding variable. So the script added a variable to the binding called trades. So that's what we're doing here. Binding.variable trades, that's a closure. We set the delegate of the closure to a custom instance or instance of a custom class, trades DSL. So what's going to happen is every time there's a call to a method, it's actually going to be resolved against our trades DSL instance. Okay? So this is all of this code is just about running the script and running it against a DSL instance. The logic of the DSL is in a separate class called trade DSL. And then we simply end up with trades DSL has a variable holdings that we can access that has that information about which stocks you have and how much of each one. Okay, so this is our trades DSL class. Remember, it's in Java. We can write it in Groovy as well, it doesn't matter. But the key point is you can write it in Java if you want. All you have to do is implement methods. So remember I said buy, sell. That was the method, that's the implementation. Buy takes a quantity, an integer. So we've got buy 1000. And that returns the trades DSL instance. Sell is exactly the same. And then we have of. So remember, we've got buy 1000 of, and then the epic, which is VMW or what have you. Now, key point here is that takes a string, but VMW and MSFT, they were not string literals. So how is that done? Because we don't really like string literals if they're not necessary. We override get property. Every time Groovy can't resolve a property or method, it goes to some underlying methods. So a bit like method missing in Ruby, I think. So you get property. Every time, so VMW, it says, that's a variable, but I can't find it. So what it does, calls trade DSL and says, okay, what's this property? And so trades DSL says, well, actually, it's just the name of the property as a string. So we return name. And that is the entirety of that DSL. Not a lot of code, even less code if it's in Groovy. And stock holding is just the data class that's holding our stored information. And then if we run it, we'll get what we expect. So the user starts off with 1,000 of each share. We're adding another 1,000 and then selling 400 of EMW and so on and so forth. Okay. So some people think it's quite difficult to implement a DSL, but it's surprisingly easy. The really hard part of DSLs, is the error handling. Because what you really want is, if somebody mistypes of, and they have OFF, for example, then you will get a missing method exception. And to users of the DSL, that's kind of, okay, what do I do next? What does that mean? You'll get a relevant line number, but if you've got business users, that's not really going to help. So the hardest part is implementing the logic of, if there's a method missing exception, for example, you've got to trap that and provide a relevant error that your end user is going to understand. Now, while we're on the DSL, that whole project is built and run with a Gradle tool, and that's the whole of the build file. So you say it's a Java project. That means that my source files are in SLC main Java, just like a standard Maven project. I can also generate Eclipse files for it, just by applying the Eclipse plugin. Application, main, class, name. Okay, and that's it. So application allows you to both run the project from Gradle and also to create a runnable application. It packages it out. You can provide it to other people and they just have a script that says run. So quite useful. Very quickly, Groovy. Hey, if you're a Maven user, and you have to use Maven, then you can use the new Maven compiler plugin. So that's actually using the joint Eclipse compiler. So it allows you to compile Java and Groovy together within a Maven project. Gmaven also is a separate plugin, and that allows you to define plugins. I think Maven plugins write them in Groovy. But for simple Groovy Java joint projects, Maven build, you can do that. Okay, this is just a very simple example of a joint Groovy. You have Parrot in Groovy, you have cat and main in Java, and say in Java, and they depend on each other. Okay, so finishing off on the Groovy ecosystem. If you do desktop application development, so has anyone done Swing? Or are you all too young to have done Swing?
Not in a long time.
Not in a long time. Exactly, but apparently it's not dead. Well, there's also Java FX, which is effectively superseding Swing. But if you want to do desktop application development and you don't need to do it for your iOS devices, and you don't have to use Objective-C, I've done Swing development myself, and if I wanted to do a desktop application, I would probably do it in Java. Griffin is like the Grails or Rails for desktop application development. And it is very straightforward to get up and running, and it has a lot of plugins that will allow you to do some very funky user interface things. A lot of themes and that kind of thing. Gradle, I've already mentioned. Now, personally, I think Gradle will take over the world, or certainly the Java world, in terms of build tools. It's not there yet, but it basically takes the best bits of Maven and Ant and gets rid of all the horrible bits, except dependency management, because you just can't get rid of the nasty bits of dependency management, because it is the nasty bit. But it has the conventions from Maven, it has the dependency resolution against Maven repositories, but it gives you the flexibility of Ant. So, you apply the Java plugin, and if you've got a standard Java project, it will build it, it's got an assemble for creating a jar out of those source files, All of those things, very straightforward, but if you need to customize it, it's very easy to do so. Add your own Groovy classes, Java classes. Gradle is a whole talk in and of itself, or several talks in fact. gparse is another library for doing parallel processing. So you've probably heard of actors libraries, things like Akka. But gparse has an actors library, it has data flow implementations. If this doesn't mean anything to you, that's fine. It doesn't mean much to me, unfortunately. Russell Winder, somebody I know, is much better explaining this. But it gives you a bunch of primitives and functions and data structures that allow you to do parallelize your applications in a relatively straightforward way. And gparse is now part of Groovy 1.8 distribution. Okay, so you can try it out. Now, before I go on to Grails, I very quickly wanted to show Groovy console. Groovy 2.0.0 RC4 has only recently come out, so the 2.0 final is just around the corner. I just want to talk about the main feature that's coming, and it is static type checking, optional static type checking. So I talked about optional static types, but Groovy still 1.8 and earlier won't resolve things until runtime. So that means that if you type a name wrong, if you get the name of the string incorrect, or the name of the name field, NAAM, that will resolve at runtime. Missing property, missing method exceptions. However, with Groovy 2, see, these are actually compilation errors. Now, it's not very impressive in here, but imagine if you've got this in your IDE. It can highlight all those compilation errors in red. And of course, because it's got the static type checking, it can do type inference as well, and so your IDEs can do the whole refactoring and auto-completion much easier than it can do now. They do have very impressive auto-completion for standard dynamic Groovy, but if you're not interested in the dynamic aspects, or most of your code is not dynamically typed and you don't want that, you want your static type checking, except when you're using XML Builder, for example. You can selectively add type checking, static type checking. You can add it to a class or a method. Let's get rid of that. And if I run this now I get the runtime exception because render, the script, is not type checked. There we go. You could also, to be honest, most people seem to be worried about the static type checking. They just don't like their typos not appearing until runtime. But sometimes you do need the performance of static compilation. If you've got expensive calculations that involve a lot of calls to methods between classes, then static compilation can be a big win. And of course, because we have the type information, because we can do type checked, we can also compile classes statically. So you now no longer get dynamic method dispatch. Of course, you do need to import this class. And compile static does just that. It takes type checked, you still get that type check, but it also compiles to pure Java bytecode. And for sort of similar benchmarks, the Groovy with compile static, very similar to Java. There are some differences, but we're talking about very minimal. Did you have a question?
So there's no more reason to write Java, basically.
Exactly, yes. fact, a lot of people want Groovy as a better Java.
Yeah.
But I mean, the really nice thing here is you can very easily intermix things that are suited for dynamic language, such as the XML builder or JSON parsing or anything like that, and other stuff, compile static. And of course, you don't have to wait for Java 8
Properties.
lambdas. So, huh?
And just the properties, the getter setters.
Yeah, exactly. Yeah, because those are, I believe, still in there. Yeah. So there are some subtle differences between the semantics of statically compiled Groovy and dynamic Groovy. So you need to be a little bit careful if you're using local def variables, for example. It can infer the type, but if you change, so if you assign a string, here we go. So if we do def like that, we can do println string.cast. So it's inferred that, it actually knows that string is of type string. Unfortunately, if you do string equals 12, what happens is it goes, so you said string was a string, but now you set it to an integer. Now I'm not going to call that a compilation error. What I'm going to do is find the common base class, and that will be the type of your variable. So that's the kind of subtlety you need to be wary of, whereas interesting, although this, I may have to resolve this. If I do string like that, string is special, isn't it? Okay, so string is special because there's automated .toString on various things. So it's, I think it's slightly easier if this is int, and then you try to assign it a string. Okay, so you get a compilation error because you're trying to assign a string to an int. But see, there are those subtle distinctions with the string. It's useful that it will automatically apply a .toString when you're assigning to a string, but it means that some things that would be called in Java wouldn't be called in static Groovy. Okay, so anyway, that's coming, that's RC4. And I think that will get a lot of people very interested. How are we doing for time?
Maybe we have another 15-20 minutes.
15-20 minutes, okay. Really wanted to spend sort of more time on Groovy. So I'll quickly go through Grails. I'll probably show a quick demo at the end. So Grails is to Groovy as Rails is to Ruby. It's the simple setting point here. Rapid Web Application Development Framework on the JVM with the first-class Java integration. Now, we're not just talking about integration with Java the language, we're talking about Java the platform. So that means integrating with Maven repositories. It means integrating with things like Spring and all of those classes. So, and the libraries, all of those things. It was inspired by Ruby on Rails, but it does do some things quite differently. So what do you get? You have the whole WebMVC framework, you have your GSP views, server container, GORM for doing your data access, that's to simplify Hibernate basically. You get an in-memory database, you get internationalization support, all of these things, even an engine for generating documentation for your project based on a wiki syntax. And all of that comes when you download and install Grails. It is built on top of Spring and Hibernate. So you guys familiar with Spring? You know, yeah.
Mhm.
And Hibernate for the data access. Unlike standard Java web projects, you get a structure, a project structure that's pretty unique, similar to the Rails one. And that makes it actually much easier to navigate around projects if you're just using a text editor. But you know, the IDEs have pretty good support for this. So you group each type of class, controllers, the database, domain model, views and layouts. Each of those get their own directory. And the idea is that you don't have to worry about doing any of the plumbing yourself. You can really get started very, very quickly. I'll do the demo at the end. Now, the demo is basically you can declare a domain model, author and book, generate a CRUD, create, retrieve, update, delete, user interface for the web. It literally takes a few minutes. But that's not just what Grails is about. And the idea is that really you can use it in the Java enterprise. You can make use of the various Java libraries out there. You can make use of all the Spring classes that are out there. So you can add messaging. You can support the legacy databases that you might have to. You get integrated services for easy transaction support, and basically decoupling your web layer from your business logic. So your web layer shouldn't really be accessing the domain model directly. There are real benefits to abstracting it away. And services become your reusable logic. And that means that you can put a web services gateway in front, or a REST interface, or an HTML-based UI, or all of them, plus your iOS mobile clients, that kind of thing. So build, again, you can't build a standard Grails project with any tool natively, even Gradle at this point in time. So what we have is adapters to allow you to build via, say, Maven or Gradle, and they just hook into the standard Grails build system, which is based on something called Gantt. Grails 2.1 is coming out very shortly, and that has much improved Maven support, and we've got quite a few people testing it out. And that allows you to have Grails plugins and Grails applications as part of multi-project Maven builds. Yeah. Dependency DSL, this is how you integrate with the Maven Central, that kind of thing. This is dependencies and repositories. Very easy to care custom repositories, say your Nexus, if you put that in front of, say, Maven Central. And then you declare your dependencies using a much more succinct syntax than Maven. And this is where you declare plugins as well, things like Spring Security if you want to add access control. Legacy databases. So the idea here is that in certain circumstances you do not have control over the database. It's a sad world when that happens, but it's all too common. So you don't really want to lose the benefits of GORM, but you can't use the standard database schema that GORM will generate for you. So fortunately you have various options. You can, within your domain class, we've got a book here, you can have a static mapping block, and within there have customizations. So you can change the name of the table, the names of columns, you can change types. So we can say title is the type, I think that's actually wrong, you can say title is the type text, or character blob if you want a really, really, really long title. So you've got that level of customization. That can take you so far. Sometimes there are some really, really obtuse and nasty database schemas. For those, simple custom ORM mappings won't work, and then you have to use really delve into the Java world. And that means using either JPA annotations. So those are annotations that are on typically Java domain classes, and you can load them into Hibernate by declaring them in a Hibernate configuration file. The point is, that's an option. And hey, if you've got an existing project with a JPA domain model that's in a jar file, you just put it on your Grails project class path and populate your Hibernate configuration file and you're sorted. Otherwise, you can use standard Hibernate XML mapping files. Okay. So is this relevant to anyone here? Kind of, no.
Crazy.
These particular things. Things like
Crazy.
legacy databases and having to deal with those. Yeah. Okay, so I'll swiftly go through these then. When your model is outside and in Java, then you might think that you lose access to the whole validation framework, but you don't. You can add the constraints for domain classes outside of those classes. You just put them in a separate file. That's the convention. That's your domain class name. Your directory structure matches that, and you've got book constraints.groovy. Gorm JPA plugin. I'll skip that. I think that's irrelevant to you guys. That's for people who want to use the JPA entity manager. So for a long while, you had a couple of choices when it came to database migration. So when you've got a schema-based database and you've got production data in there, and you want to go from one version of the application to another, you don't want to use Hibernate, because Hibernate can't handle things such as a simple column rename. So typically what you do is, when you first start with Grails, you have Hibernate set up with update or create drop. These are settings that determine whether it creates the database schema and how that behaves, whether every time you start the application, does it drop the whole schema, or does it just keep the schema with the data in there and try to make the changes to it. And that's what update does. So a lot of people are lulled into using update and thinking, hey, we can just use update every time we just change our application, deploy it, and boom, everything's good. Update will do everything we need. But as I said, it doesn't work in all circumstances. So if you go to production, the first thing you should do is install database migration plugin, and then you work with change logs. Under the hood, this is using Liquibase, but here you're dealing with database refactorings. So in your change log, you're saying rename column or update data in this table using a SQL statement. Create a table, add a column, remove a column. These are the types of refactoring that are supported by Liquibase and by extension database migration. Is that a question?
Yeah. Could you do something right now real quick where you put the presentation? Because I have to go.
Oh, right, okay.
There'll be an announcement on the meetup site. Okay, I'll send an email with the video and the
I'll pass that on, that's no worries. Okay, so the neat thing about the migration plugin is you start with dbm generate change log. So what that will do is take your existing schema and generate an initial change log for it. So you don't have to manually set that up. You don't have to do any SQL yourself. And then change log sync just basically tells the current database you've already applied this change log. You then change your domain model. This is your next version of the application. And then you can run Gorm diff. What that will do is compare your Gorm domain model against the database and then generate a change log which you can add to the whole to the overall change log. And then when you deploy the application, you can either execute those change logs to migrate the database separately, or you can configure it to migrate the database as the application starts up. That's what we do for Grails.org. Reverse engineering plugin allows you to take a database schema and generate a warm domain model. And here we go on to the fact that Grails is Spring. Spring MVC under the hood, so I don't know how many people actually know that, and it comes with a lot of useful Spring beans. Grails application allows you to interrogate what controllers are available in the application, what domain classes are there, and do all sorts of things like that. You can also define your own beans, override existing ones, and really take advantage of the benefits of Spring, having that inversion control in that. And many plugins do this as well. So, for example, Mail plugin will add a mail sender bean. Okay, so what's that look like? So Spring in Java land has XML definitions, you can use annotations, you can also use Java config. Grails has an extra one, which is called Bean Builder. This is a little bit like the XML markup builder, except it's for Spring Beans. So you've got the name of the bean, credentials matcher, of type SSH1 credentials matcher, and you can set properties on it with an enclosure. Very straightforward. One of the key advantages of it's declarative, but you can put code in there. You can put conditions. You can say for production environment, I want this bean implementation. For development, I want another one. So for testing and development, you may use Greenmail as a dummy SMTP server. For production, you might use Amazon's simple email service. So that's the kind of thing you can do in this file. And of course, with Spring comes in all of those features for integrating with the enterprise. Spring integration allows you to do interesting routing of messages within your application, and it allows you to send messages out to the outside world, either to AMQP or JMS, your message brokers. It's effectively a replacement for the ESP buses. But you can integrate with all of these, everything. Okay, and you get Grails plugins which simplify access to all of these libraries. Routing is basically Apache Camel that just integrates that in. RabbitMQ, so you can install the RabbitMQ plugin and say to this service is a subscriber to a particular topic, and that's it. Every time that a message comes in on that topic, the service method will be called. So lots of options for integrating Grails with like Maven, Gradle and that kind of thing, and working with existing systems. So have you seen Grails in action from a first? So it's almost not worth doing that demo. However, I do have an example app up and running. So this is using legacy DB now. Okay. I don't think this one is going to run, which is unfortunate. Okay. This is why I record demos so much more reliable when you get there. So here's an example of that resources.groovy. So we're actually using Spring integration here. It's kind of like the XML notation, just using the Groovy code instead. So what we do is we set up a main channel, that's where our messages are going to go through. We add a wiretap interceptor, which is going to send messages to a logger channel, and that's basically just going to log to the console. And also our service activator, which calls audit service dot message received method. And then the service is audit service, and that one instantiates a new audit domain class. Notice there are no annotations. What we've done is abstract the message away from the classes. So audit service has no knowledge of Spring integration whatsoever. That's all wired in at runtime. And then the actual sending is done like this. So we declared main channel. So we can just add a property to our service called main channel, and the channel will be injected, and that will automatically have a send method on it. And then we're sending a generic message. And then that will create audit events, audit domain instances, and it will also write to the console. I'm guessing that there are some things that need commenting out. There we go. Okay, and that is pretty much it. I'll see whether this starts up. If not, I'll need to have a look into this. So Dynamic Controller Manager is used by something called App Info plugin, and that allows you to interrogate the application. It can show you all of the Spring beans that are in the application. It allows you to work with the app logging configuration, hibernate statistics, all sorts of things. So I think it's just not going to...
Login configuration at runtime?
Login configuration at runtime, yes. So,
Very good.
audit admin manage control, I think, is the one. Okay, this is where I'm going to double check on the login. No, it may not do that. You do get hibernate statistics. Obviously, I haven't tested this for a while. So you can see what the hibernate second level cache is doing. So for actually runtime logging, I think you need the runtime logging plugin, but that will give you access. And of course, Spring beans, and there literally are, it's 144 entries in there. So this is a good way of finding out what's available. Okay. So, I'll finish off there. So. That's pretty much it. I can also, afterwards, talk about Cloud Foundry and Cloud if you're interested in those topics. Okay. Anyway, thanks for coming. Thank you for listening.
Thanks, Peter.
Any questions, and let me know afterwards. And glad to be here. Okay.
Thank you.